Good afternoon, everyone. Thank you for joining us. Welcome back. I'm Steve, and I'm much happier.
And I'm Scott, and I'm the same.
And together, we're Backyard Musings, the Science and Technology channel.
Yeah, and we are talking about space and the sun.
Yeah,
And
very interesting.
yeah, we like
Thanks
talking
to
about
James
space.
Webb, James Webb Telescope.
Yep.
All right, new research suggests our sun was part of a huge migration of sun-like stars that moved away from the Milky Way center billions of years ago. Scientists have found new evidence that our sun may have been part of a large-scale movement of similar stars that left the inner regions of the Milky Way about 4 to 6 billion years ago. Using data from the European Space Agency's Gaia satellite, researchers built and analyzed an exceptionally detailed catalog of stars and their characteristics. Their results provide important clues about how our galaxy evolved, especially the formation of the rotating bar-shaped structure at its center. I call it stellar cartography. Got that from Star Trek. Would you like to know more?
On Earth, archaeological exams, archaeology examines the past through artifacts and ruins. In space, a similar approach called galactic archaeology investigates the history of stars and galaxies. Scientists already know that the sun formed around 4.6 billion years ago at a location more than 10,000 light years closer to the center of the Milky Way than its current position. Okay.
The chemical composition. Say again?
I did not know that.
Yeah. Drift, gravitational drift.
Okay.
Over billions of years, yeah. The chemical composition of stars supports this idea, but it has puzzled astronomers for years. Observations of the Milky Way reveal a huge bar-like structure at the galactic center. This feature creates what scientists call a corrotation barrier, a gravitational effect that makes it difficult for stars to travel far away from the central region.
To understand how the sun could have reached its current location, a research team led by assistant professors Daisuke Taniguchi from Tokyo Metropolitan University and Takuji Sugimoto from the and I'm sure I butchered those names, sorry, National Astronomical Observatory of Japan conducted an unusually large investigation of solar twins. These stars closely resemble the sun in temperature, surface, gravity, and chemical composition.
The team relied on observations from the Gaia satellite mission, which has mapped roughly 2 billion stars and other celestial objects from this enormous data set. The researchers assembled a catalog of 6,600 solar twins. This sample is about 30 times larger than those used in earlier studies.
With this expanded catalog, the scientists were able to determine the ages of these stars with greater precision than before. They also accounted for selection bias caused by brighter and easier to detect stars being overrepresented in observations.
When the team examined the age distribution, they found a noticeable concentration of stars between 4 and 6 billion years old. The sun falls within this same age range, and many of these stars appear to occupy similar distances from the galactic center. This pattern suggests that the sun did not arrive at its current position by chance. Instead, it likely moved outward as part of a much larger migration of similar stars.
The discovery also offers insight into the Milky Way's development. Under normal conditions, the corrotation barrier created by the galaxy's central bar would prevent such a large-scale movement of stars away from the inner regions. However, the situation would have been different if the bar structure was still forming at that time.
The ages of the solar twins indicate not only when this migration likely occurred, but also the period during which the central bar took shape. In other words, the outward movement of these stars may have happened while the galaxy's structure was still evolving.
The inner regions of the Milky Way are far harsher environments than the other parts of the galaxy. Radiation levels are higher and stellar interactions occur more frequently near the galactic center. The team's findings suggest that the sun's journey away from this crowded region may have helped place our solar system in a more stable location. The quieter part of the galaxy provided conditions where life on Earth could eventually develop and evolve. Had to be some higher power with it.
Doesn't it fit into a higher power's plan? You know, that
Absolutely.
whole thing?
Absolutely.
It does.
Yeah.
It does.
Yep.
Everything has to obey laws.
Yeah, and things are constantly in motion, right? That's what we're talking about here. Constantly in motion.
It's a neat story. Really enjoyed it.
Yeah, pretty cool. Pretty cool.
All right, folks. Thanks for joining us. We'll catch you on Monday. So enjoy your Sabbath.
Okay. Have a great weekend, and enjoy your Sunday, and we'll see you Monday. Thanks.
See you.